So today we're going to be talking about a couple of news items for you, and the first one is another U.S. government award for 3D printing. This time, a company called Applied Research Associates, previously got $12 million from the U.S. Army's Engineer Research and Development Center. Now is giving $3.5 million of this money to the University of Arkansas. The College of Engineering there will use the money to basically improve 3D printing of concrete. The idea is to 3D print culverts, T-walls, and Jersey barriers, although we can all imagine that and it's particularly horizontal structures, but I think we can all imagine that the United States Army would also like to print barracks, reinforced kind of positions and things like that. And silos and other kind of structures. The award is to be headed up by Michelle Berry, a professor, along with Cameron Murray and Wenchao Zhu. Wenchao is a professor, but he's also a founder of Ambolts. And Ambolts is the swarm construction or swarm manufacturing startup that you saw. So the vision here is clear. They don't really talk about this, but imagine from a military standpoint, you had a swarm of autonomous robots that could build you a base or build you a reinforced position even before you got there in a contested area. There's of course applications beyond this in things like disaster areas and things, reconstructing things, but the military applications here would be quite considerable. What they're going to be, the team of 3 professors, they're going to rope in as many as 18 students or more, and they're going to be looking at nature-inspired structures, material reduction, also mixing in local soils. So the idea is to have a kind of recipe bank of different types of soils that could mix in with concrete to reduce the amount of material they have to bring to the States to wherever the troops are. They're going to be doing structural testing. They're going to look at CAD to toolpath. And yeah, the potential is huge, and this seems like a really comprehensive product here to really look at 3D printing concrete as a technology and to really refine that technology. And an army famously marches on its stomach, and the amount of, if you can just bring less material with them, they have less soldiers to protect the soldiers that need to bring the material in. And this makes the entire army more efficient, and it can also let them build up structures or improve structures, or build improved structures to improve threats, or build structures like, as I said before, in an area you could march towards the area. By the time you're there, that could be a trench or that could be a base there already, and that could be very advantageous. And again, yesterday we talked about a $100 million award to the University of Wichita for 3D printing vehicles, and we also talked to a several $1 million award to the University of Arizona for hypersonics. So, or I think it's a $1.2 million award, that one. So the United States military is investing some very, very serious money publicly in research, and we know that there's actually much more going on. The next thing is about, Aerosol Optometric Jet, and this is something we feel we need to bring to your attention again, because Aerosol Optomec's Aerosol Jet technology has been used for electronics and IC packaging and things like that for a while now. There's even rumors that it's been used for antennas and interconnects on millions or perhaps billions of devices, but we can never get anyone to substantiate this for us. Now the company is releasing a proprietary software called KEWB, I don't know, which is specifically meant for high volume electronics manufacturing. So they have a scripting ability in there, they have an automating sequencing ability, some more better process control, some IoT connectivity stuff. And this goes in lockstep with their release of the Aerosol Jet HD2, which is specifically meant as a semiconductor packaging 3D printer. This can print feature sizes up to 10 micron, layer heights as thin as 100 nanometers, which is wow, by the way, and as thick as 10 micron as well. And this machine has better productivity and alignment, and it's meant to be used in kind of like really high volume electronics applications. So we're really working towards the industrialization of electronics manufacturing for things like smartphone antennas, IoT, sensors. Optomec has sold over 600 systems, which includes these Aerosol Jet, but also lens systems to over 250 customers. And we're looking at chip packaging, integrated circuits, antennas, packaged dies, all this kind of stuff. And just this IC packaging market alone is a huge market, not only in for 3D printing as a device sales kind of opportunity, but also this gives us the opportunity to make billions of devices. And we're further along in that sense that you think. Like, so The weird thing is that electronics manufacturing or 3D printing electronics has been overblown for a long time, and everybody's been there's been a lot of overclaim about people's capabilities. But in making IC packaging and some electronics components and inkjetting on and jetting onto electronics components, we're probably much further along and much further closer to production than we think. We're assuming at 3dprint.com that we're actually doing production of at least hundreds of thousands and potentially millions of devices as we speak. Only no one's been able to confirm this, so that's kind of annoying, but very, very exciting at the same time. The next piece of news comes to us from Switzerland, and this is news about a 3D printed insole. This is a paper that was in Nature by Gilberto Sequeira, Marco Benelli, Ryan Domelin, Yannick Nagel, and a bunch of other people at ETH Zurich, EMPA, and EPFL. So essentially, it's kind of like everyone in Switzerland kind of collaboration. And it's about a 3D printed insole. Now, this is a 3D printed insole where they've 3D printed the electronics into the insole. People have done this. Echo did a kind of a concept with this a while back, but this is an actual practical implementation using direct ink writing. The idea is that using silicone, cellulose nanoparticles, and conductive silver inks that make this insole is then can measure your performance while you're walking, while you're running, while you're doing things. So imagine an athlete wanting to improve her performance. We can not only look at her walking on a mat or being scanned or having all sorts of stickers on her or something like that, walking up and down in an office. No, we can actually see, track her performance when she's training, right? When she's doing her training routine. Or if you would like to walk more comfortably, we can give you this sensor for a week, and then we'll see where you need advice or where you need help. And imagine, I like this application. They don't really talk about it, but imagine for a prosthetics user, you could just map this to the person, and then the person could wear this for a while, and you can see where you would like to make that prosthetic more comfortable. So I love this because this has a real potential of really changing how somebody wears shoes. Imagine you wear it for a week, and then we print an individualized, voxel level customized sole that is just for you, that could make you more comfortable. We spend a lot of time walking around, especially like people like mailmen, UPS people who are in walking type professions, waiters, some people like that. And for them, just a marginal improvement in that area to have a customized insole that is specifically for them, and specifically made for their lives, if you will, rather than just a scan of their geometry, that would be, I think, a hugely impactful thing. Now, that would need us to change our behavior a little bit, and that's always very difficult to do. So we don't know if this is going to actually happen, but I think it's wonderful that this team is working towards this. And I see the applications in health improvements. Imagine people with like back pain, and the alternatives is like taking an opioid or taking a surgery or something like that. But this can be alleviated by just having really, really highly functioning insoles. Things like that. I think of this not only in sports medicine, podiatry, prosthetics, lots and lots of areas. I think this would be a wonderful, wonderful tool. The next thing comes to us from MIT. It's from Marwa Al-Alawi, Michael Wesley, and Stephanie Mueller. Basically, they've done is found a way to use 3D printing, conductive 3D printing filament and a multi-material 3D printer to embed rotary encoders inside 3D printed objects. The idea is that in a one pass, very simply inside of an existing production system, something like a gear or another device or a hinge or anything really, any kind of assembly, you can embed this encoder, and then you can see the position, the speed, and the direction of the rotation, and even if something like a door has opened or not, or even count the number of times a gear has been moved or something like that. So imagine this, you can actually embed a lot of performance tracking into a lot of assemblies, a lot of complex assemblies. Think of a car gearbox or a hydraulic component or like kind of like any kind of big mechanical component. But also think of like adding encoding and signaling in some way to a light post or some kind of device like that. It seems like a very facile way to do this, and I think this is a very interesting thing that the team been working towards. In that paper, it's called MechSense, Design and Fabrication Pipeline for Integrating Rotary Encoders into 3D printed mechanisms. And they're also doing a SolidWorks plugin, actually, so they want to make the design of this quite simple, which I think is quite the idea, actually. Anyway, my name is Joris Peels, and this is another edition of 3D Printing News Unpeeled. I hope you have a wonderful day, and thank you for your time, and thank you for listening.